introduce you to the wonderful man in the front row, Cameron Balahan. Cameron is the Group Product Manager at Google. He's flown in from New York for this session today, so I think we've got to say thank you to Cameron for that. And he's going to explain why Go is literally, quite literally, good for business. So if we can have a GopherCon UK 2024 welcome for Cameron.
Thank you, Donald. All right, thank you, everybody. Thanks for making it out, and I hope you're ready for another awesome GopherCon UK, the 10th it sounds like, so it's special. Before I begin, join with me to give a huge thank you to Sam, to Donald, to Blue, to all the staff here for making this event happen again this year. So, as Donald said, I'm Cameron, and I'm the product lead for the Go programming language at Google. In this presentation, I'm going to tell you a little bit about the business of Go. And generally what I mean by that is I'm going to tell you how we, the Go team, think about our market, our stakeholders, our strategy, and sort of our future as a programming language. So before we do that, let's talk about who I am for a second. It's totally normal if you don't know who I am. I've been on the Go team for about 4 years now. Prior to Go, I led product for the Google Cloud SDK, including like languages and frameworks integrations. And before Google, I was a software developer at a high-frequency trading firm where I built low-latency trading systems for US equities, almost all of that in C++ and Java. And I didn't actually really use Go much until I joined Google, but then I found Go and I became a huge fan almost instantly. And now I'm lucky enough to lead product for the team. It's just the highlight of my career, in large part because of the dedicated community like all of you in this room. So, thank you for making my life fun. All right, so on to it. One thing people sometimes wonder when I tell them that I am a product manager for Go is, why does Go even have product managers? I'm guessing some of you are probably thinking that right now, if not all of you. What product management even is, in general, is sort of hard for me to define because it's so, company and product and role dependent. And even within Google, it varies quite a bit from product to product. So I skimmed through some of the books that I have in search of an answer, like what is a PM? And nothing really satisfied me. But I did find this one pithy statement in this random internal document at Google that I really liked. Product managers deliver the right experience to the right market at the right time. And they do a lot of other things too, so I like to leave like a caveat at the bottom, and a bunch of other things. But this main sentence, it covers a lot, so I want to break it down. So the right experience. And what I think this means is that product managers define what the product is and why we're building it, but not necessarily how it's implemented. The what means understanding, user requirements and the value users are going to derive from our product. The why means understanding, sort of the bigger business context for this product. Why does this further the goals of our company, of our organization? And then implicit in both the what and the why is understanding what success looks like. How do we know we're on track? How do we measure progress? And then the right market. This is understanding, the broader market context in which our product competes and adds value. It's also an understanding of the customer segment that we're targeting. So this is important because it enables us to make trade-offs and sort of understand priorities. So if you, try to be the best at everything, you're probably going to end up being average at everything. So you have to know what you're trying to accomplish, for whom, why it matters to them, why it matters to your organization, and then sort of guide your decisions accordingly. And finally, the right time. So here, we've got to prioritize, based on that market context and the target customer segment we defined earlier. We got to come up with a roadmap. We have to pick between competing priorities, and then we have to lead a successful launch. So I'm going to step through each of those things, the right experience, the right market, the right time. But I'm going to switch around the order just a tiny bit because it makes more sense to think about the market before the experience. So let's take a look about what we know about Go's market. So before anything else, I'm going to introduce the product adoption lifecycle. So you've probably all seen something like this before. It's a really useful way to kind of divide your market into segments of users based on when they adopt your product, because that can give you a lot of insight into their needs. You know, innovators and early adopters, they come first, and they have these certain characteristics, and then the rest of the market, you know, may or may not follow, but if they do, they have their own characteristics. Now, building on that some more, these innovators and early adopters are what we think of as the early market. So the early market is tolerant because of incomplete products. They really respect innovation, they want to try new stuff, and they understand that that may mean that stuff is under construction. The mainstream market, on the other hand, you know, they're more demanding about this. Sure, they like innovation too, but they don't care quite as much like the early market does. Instead, the mainstream market is more interested in convenience and sort of complete solutions. You know, the priorities are different. Now, in between these two markets is what we call the chasm. And the thing about the chasm is that the vast majority of products will spend their whole existence in the early market unable to cross into the mainstream. So crossing the chasm, it's a really big deal for any product. Now, I bring all of this up because programming languages follow this life cycle too, you know, just like any other product. The vast majority of languages never get past the early market part of this, but then a few do. And that provides really meaningful context on the users and the overall market. So for fun, I asked Gemini, what are some well-known examples of products that didn't cross the chasm? And apparently Segways are one, which I don't have too many thoughts on. But Google Glass is the second one, seems right. Did anyone own a Google Glass by chance? Oh, just one person who works at Google. I owned one too. What about a Microsoft Zune? Did anyone happen to own one of those? All right, Bill Kennedy did. I did too, Bill. And then 3D TVs? Nobody. Oh, someone out there. I didn't own one of those, thankfully. Anyway, so if you're intrigued by the value of the product adoption lifecycle, the next thing you might wonder is, well, how am I supposed to know sort of where I am in this lifecycle? And that's where the shape of this curve has some value. So these segments, they represent kind of like specific proportions of the total market. So if your market has like 10 million users and more than 16% or like 1.6 million of them are using your product, you're past the chasm. Which begs sort of the next question, which is how do you know the size of your market, or how do you even know what your market is? So in programming languages, one way to work this out is to think about the problem domain that you're addressing. And how we define a problem domain is itself sort of a core strategic decision, because you want something that's not too broad, because then that won't account for sort of incompatible constraints and priorities. And you don't want something so narrow so you're sort of creating undue fragmentation or overhead for yourself and for your users. For Go, the problem domain we focus on the most is the cloud. And to be clear, Go addresses sort of general productive server needs in any environment, cloud or not. But more and more of these workloads are or will be cloud-based in the future. And in programming languages where users rarely go back to rewrite existing software, the cloud is where we can look forward and ensure that we're really providing maximum value on a forward-looking basis. So when we look at where Go sits in the cloud problem domain, when we look at the size of the market, how much of it Go's captured, its growth moving forward, it's kind of clear that Go crossed this chasm years ago. First, this is like tremendous. Crossing the chasm is a really big deal in any product, but for programming languages, it's an even bigger deal. And that's because programming language adoption is so slow and deliberate that it can take like a decade or longer for programming languages to cross this chasm, if it happens at all. And second, since we know where we are in the adoption curve, we know that the next cohort of Go Cloud developers are going to prioritize things like complete solutions and convenience. So we know that that's our target audience. Now, thinking about what a complete solution might mean, how many of you are familiar with the DevOps infinity loop on the slide? Some? All right, cool. I think it's a decent way to sort of think of the broader software development lifecycle. You can think of the loop on the left as what we call the inner dev loop. It's where you're writing code, you're iterating quickly, you're looking for quick feedback and productivity. And you can think of the loop on the right as the outer loop, the one where you deploy your code into production and then you sort of monitor it and operate it. And so when we think about creating complete solutions, we think about solving end-to-end across this whole thing, inner and outer loops. So say we want to solve for developer velocity. So it's one of Go's signature priorities. Go has all of these features and tools and libraries that take everything into account to maximize your team's developer velocity, beginning from when they're writing code to pushing it into production and then operating it reliably after that. We provide IDE integrations, including our own LSP server and plugin for Visual Studio Code that make it easy to leverage the features of the rest of the tool chain. We have built-in formatting, a built-in test framework, a built-in debugger. And we do this for a variety of other problems, like security, performance, portability, and so on. One of the original motivations for Go was really to build this platform. It was all about software engineering, not just programming. So that meant solving for this whole software development lifecycle. Because to remember, the origins of Go were all about solving Google's problems with scale. We were trying to reevaluate that problem. And that meant necessarily thinking about all this stuff holistically and with an eye towards complete solutions. And now that we're on the other side of the chasm, those decisions and that vision from the beginning, they're really fortunate because they continue to fuel our growth and suitability for the next phase of the market. So now we have a sense for our market, so we know our problem domain, the adoption curve, the users we're targeting and what their needs are. So now we can think a little bit about the experience. These users we're targeting, what is the experience that we want to build for them? And why do we want to do that? And how can we measure that we're doing it right or that we're on track? So a corollary or sort of related question is kind of like, who cares? For Go, there are at least two big groups of users or stakeholders who care. First, it's you, all of our users, our contributors, our community, our package maintainers. So I'll call that Go users. So this group wants to productively build production-grade software that solves problems and which people use so that your businesses are successful and you all remain gainfully employed. So this group is successful when, one, you're productive and happy, and then two, your software is secure, reliable, and performant. The other big stakeholder is Google. So Google funds Go, and it wants a return on its investment. And there are two categories of return here. First, Google uses Go extensively in its own internal workloads. So for this, Google is successful when, one, its internal developers are productive and happy, and two, its internal infrastructure is secure, reliable, and performant. So these are the exact same things from the last slide, the stuff Go users everywhere are looking for. The sort of second category of return, and the one that's probably more interesting, is that it turns out that a lot of Google's business relies on external developers. So Google has these developer platforms, say Google Cloud or Gemini or Android, and these rely directly on developers for their success. And then there's the other parts of Google's business, the ones that are not directly tied to developers. And they're actually still indirectly tied to developers. So I'll tell you what I mean. For something like Google Ads or Google Search to succeed, Google cares deeply about the internet being, healthy, innovative, and useful. And it turns out that the things that make the internet healthy and useful are, again, the same things that Go users everywhere want. A properly functioning internet means that users trust and use, that users trust and are able to use for more and more of their needs and services, requires reliability and security in those products. A growing internet, with more use cases and innovation, requires that developers are productive and able to easily scale their businesses. So some of this like keeping the internet healthy stuff is like born from Google's internal culture and its early mission and maybe even a general sense of social responsibility. But the more compelling part is that it's good for business. Ultimately, even if these developers never use Google's products, they make the internet a better place with more stuff, and that means Google's role as the organizer of that stuff is more important, which is good for business. Even if these developers never even use Go, Go still serves as an exemplar for good software engineering, where we see other languages follow Go's lead, which makes the internet a better place, which is good for business. So let's take a look at how these priorities apply to Go more specifically. So, how we position Go as providing value for our stakeholders, meaning to you and to Google. In these 3 rows, you can think of this top row as stuff relating to productivity. It's quick to get started, quick to iterate, quick to build real, scalable production applications. So for you, this all translates into faster time to value. If your business was doomed to fail, the faster you know it, the better. If your business is a great idea, the faster you get there, the better. And the more successful you are, the more successful Google is. The more likely you are to spend money on Google Cloud or build an Android app or just add value to the whole internet that Google can organize. The second row is about reliability, which includes security and compatibility and all the stuff that reduces your long-term sort of maintenance and operation burden. The less of this burden that you have, the lower your total cost of ownership, and the more time and resources you have to focus on new stuff to grow your business. Again, as you can imagine, the more time you can spend on moving your business forward, the more successful your business, the more you invest in your business, and ultimately, the more value to Google and its priorities and its long-term growth. The third row is about the cloud. So Go is purpose-built for the cloud. The libraries and integrations and architectures that Go enable, they were meant for the cloud. They weren't retrofitted for it later. This means that you can realize the cloud's benefits faster and easier and better than you can in other languages, because there are these complete, convenient solutions for creating cloud services, which, as we know from earlier, is what users in the mainstream market demand. And again, the more successful you are, the more successful Google is. Great, so how do we know that we're on track? One thing that we know is that we get really extraordinary feedback from our users. We consistently see this really high customer satisfaction in our surveys, levels that are practically unheard of in the industry. And so happier developers and operators mean higher retention, more successful customers, and a more successful Google. And happy developers lead another important metric, adoption. So I just want to say real quick that there are a lot of different ways to measure or estimate how many Go developers there are. And it's really difficult to land on any particular way of doing this. In this case, I've taken the proportion of respondents who report using Go on Stack Overflow's annual developer survey, and then I multiplied it by /Data's estimate of the number of developers worldwide in each given year. And when I do that, things look really strong. We have 3 times the number of developers in 2024 than we did in 2020. And between 2023 and 2024, we took on 1.1 million new developers. And we're gaining ground. So while the developer population at large grows, Go is one of only 2 languages that grows faster. Meaning we're targeting the right use cases, providing the right value, and we're growing for reasons that go beyond just, larger growth in software engineering. Rust, which is the only language that is growing proportionally faster, is growing off a smaller baseline than Go. So what Go is doing here as a language that has already crossed the chasm is really remarkable. And we see Go really thriving in open source, which really bodes well as like a leading indicator of what we think we'll see in industry next. So I've said this a couple times now, but I'll emphasize it now. Programming language adoption, especially when we view it in the aggregate, it's just fundamentally slow. A lot of stuff has already been written and developers continue to maintain or improve that stuff, but it'd be really inefficient for them to go back and then rewrite those workloads in a new language. Nobody really wants to fix what isn't broken. We don't want that. That's not really what, sort of our opportunity or objective is. Our objective, rather, is to target new applications. So on this slide, we plot out the proportion of pull requests on GitHub by language per quarter for each of the major statically compiled memory-safe languages. So C#, Java, Rust, and Go. It isn't aggregated over like the last 20 years like you'll find in a lot of other benchmarks, or surveys that'll say, hey, what language do you use? This is like a quarter by quarter breakdown. So it's sort of like a first derivative. And it's of actual work, measured in pull requests. And as you can see in red, Go's ascent here, it's really pronounced. In the last quarter, it actually even beat Java for the first time. And that's really exciting for two reasons. First, because Go is growing in open source, it means there will be more libraries for developers to use. And that furthers that flywheel of productivity for all Go developers and furthers that vision of a really productive, secure platform for building production systems. And even more than that, it means that Go and the Go community are really well positioned for the future. They're ready for those sort of shifts in technology that happen from time to time when new software is written. So Go and the Go ecosystem, they're really better than ever. They're really ready for those moments. Which brings me to this last section, the last part of that original statement on what PMs do about delivering the right experience to the right market at the right time. If we want to continue delivering value to our stakeholders, what should we prioritize? What should we do next? Well, as I showed you in the first section, Go for Cloud is past the chasm. It's growing into the mainstream market, which is really great because cloud still has a long way to go. So the estimates that I've seen put cloud growth at a 15% compound annualized growth rate for at least the rest of this decade, likely longer than that. Older legacy workloads will continue to sort of move to the cloud, and eventually many of those will find Go. And also, new companies will sprout up with new workloads. They're born in the cloud, and a large portion of them will find value in Go as well. So we'll continue to do this. We'll continue to provide them complete solutions, productivity, production-grade systems. But returning to that early discussion on problem domains for a minute, occasionally there are these new problem domains that emerge. And these are extremely important for programming languages because they present those opportunities where a lot of new code is written. So, as I said, programming language adoption is slow. We've established that. But sometimes there are these watershed moments that kind of establish new ecosystems and then dramatically accelerate adoption. You can think of maybe the 1990s with sort of the growth of the internet, and that created an opportunity for Java for enterprise workloads. Or maybe the 2000s with mobile or Python for web servers. Or the 2010s with cloud and Go's ascent there. And a key point is that when we solve new problems with an existing language, we can create a new language ecosystem. And if we can create a new language ecosystem for an existing language, that means that different ecosystems for the same language might coexist in different points in the adoption lifecycle. So I think a good example of this is Python, where the web server's problem domain has long matured, it's long been established, and that's kind of almost made it a finished, complete option, maybe to a fault. And for other use cases like data science and generative AI, Python is at a different stage of the life cycle. For data science and traditional machine learning tasks, Python's on top. It's the language for this, well into the mainstream market and no question about it. And for generative AI, which is, probably way too new of a space to really assess that well, it's clearly got a lot of traction. I would say not yet to the mainstream market because probably the mainstream market doesn't exist yet. So I say all of this because generative AI is a new problem domain. It's an early market, and so far, sort of Python has sort of led the way a bit, but it's probably not across the chasm. And when we think about Go's future, and we think about how to address new problem domains, well, maybe there's an opportunity here. More specifically, we see an opportunity for Go to meet demand for production AI use cases. Not data science or as like a head-to-head competitor to Python, but production AI as like a complement. So I'll show you what I mean here. I'll disclaim again that generative AI is new, and so more speculation than average here. And a lot of norms need to be established. But one thing that we've all seen, I think, is that Python's done really well in every aspect of AI. And that's because Python is this language of data scientists. And at this early stage of the life cycle, that success in data science has been the most transferable to the other parts of this new domain. It's great for working with data, developing models, using its rich ecosystem of data science libraries. If you simplify the AI process into sort of these 3 steps on the right of the slide, so data work, modeling work, and production serving work, Python really is the best tool for the job in this part in blue. The part where you build models, fine-tune them, explore them further. And so by virtue of being really good at that part, Python has sort of excelled by default in these other parts as well. But these other parts of the cycle, data processing, data preparation, model serving in your product, this is the stuff where maybe you need a production-grade language. And here, Python isn't really the right tool for the job anymore because it's not really meant to scale. You want the features of static languages, type checking, compilation of machine code, all of those things. Those are the things that enable scaling to larger programs, large development teams, and large systems. In fact, production systems, they require their own ecosystems of libraries and tools that enable developers and operators to work effectively at scale. And this is where Go shines. Reliability and security, performance and scalability, low maintenance and operational costs. This is where Go is the right tool for the job. So perhaps not surprisingly, Go developers think this too. Many of them have started writing AI-powered applications in Python because that's what the tutorials online are doing and what many early SDKs focused on. But they often hit a wall once they want to go to production. One respondent to our semi-annual developer survey put it like this: fast compilation time, statically typed variables, concurrency. I'm annoyed by the amount of type errors in Python. Writing our services in Go would dramatically decrease the amount of bugs and make our services faster and more durable. Indeed, that's the value of Go. And that's my main ask of you, the Go community. Our ecosystem is larger and more robust than ever, and in this sort of new paradigm of generative AI, we've seen a lot of really high-quality tools and libraries written in Go or for Go developers emerge. So there's some examples on this slide like Ollama, Local AI, LangChain Go, Google recently released GenKit. Many of these are written in Go, and they demonstrate the value of Go in this new space. But this is what we think one of those moments where a whole lot of new code is written. And we need more of this stuff. We need more libraries, more tutorials, more write-ups. Quality libraries and materials like this make everyone more productive, and they unlock new opportunities that we as the Go team, we could never do on our own or sort of foresee in every way. But I'm pretty confident that we'll do it. We'll succeed. And I'm confident because of you, really, the Go community. It's an important point. Remember, Google funds Go, but Go is an open source project. You can look at the license. It belongs to all of us. And there are hundreds of thousands of Gophers around the world who meet up. They come to conferences like this because they love Go. And together, I have a lot of confidence in what we can accomplish. And I can't wait to see what we do in the next problem domain and sort of all the ones that follow. And that's it. Thank you very much.